Intel is opening up for UEFI, and something that you may see Intel bringing to future Plugfest. The subject of this is the type of hardware that we use for general UEFI development, not the platforms that are made by many of the companies in this room for sale, but what kind of development platforms, what kind of systems do we have available for people who want to get in and use UEFI, and how do we encourage that for a wider audience? So I want to go over kind of the state of the industry and what Intel has already been doing to try to encourage this type of development, and then see what type of products and things we can do to encourage development, especially in the open source area. And I'll introduce a concept that many of you in the room might be a little worried about called open hardware. Don't worry, I'm not going to try to take any of your products away. This is just something that we're going to be taking advantage of for UEFI development going forward. Okay, so good news. All of us in this room are very good at our jobs, and UEFI adoption has gone up tremendously, especially in the past 12 months. Some operating system came out of somewhere in Washington State in the US. Little impact on the adoption of UEFI in general. But in the client and server markets, it's been extremely strong. It's also a high adoption rate for operating system vendors and independent hardware vendors, what we call IHVs. So if you go out and get Linux, there are a lot of Linux vendors that come to UEFI Plugfest. There are even Linux vendors that don't come to UEFI Plugfest that have Secure Boot. Distributions I had never heard of before were announcing they had Secure Boot several months ago, so that's very good. IHVs, if you go out and get graphics cards, there had been an early complaint that when UEFI boards came out, there weren't a lot of GOP drivers. When they turned on UEFI mode, their video went away. That's less of a problem now. There are a lot of retail cards now that have very good UEFI drivers, and it's mostly because of the work we do at this type of event. But of course, there's still work to be done. Otherwise, there wouldn't be another UEFI Plugfest. If we had all been done, I'd still be in the US, and we wouldn't be sitting here in this hotel. So what do we have to work on? Right now, there's basically, the way that I organize it is three kind of areas where we can improve UEFI development, and not for the people that are already doing it. If you're a very experienced UEFI developer, if you've had the misfortune of having to hear me do one of these talks before about what you should do right or what you may be doing wrong, you've had experience with this. But there's a broader area in the computer industry where we still have to get people using UEFI. There still aren't enough preboot applications. There's still operating systems that don't have support. There's still people that don't honestly know much about UEFI, and they talk badly about it because they don't have the development experience. So in this area, we can make an improvement by coming up with new development kits for UEFI, having a lower cost option for someone to start developing in UEFI, and looking at different open source options on how we can make this work. So UEFI development kits. This is a concept that Intel has had for a number of years, and there are other companies, there are bias companies that have sort of a pre-made consumer platform that they've done some conversion work on, and it's made easier for testing out drivers or operating systems. So the example that a lot of you in the room have seen from Intel is what we're codenaming Tunnel Mountain. The official name is the Intel DQ57TM UEFI Development Kit, or UEFI 231. It's called that because our legal department gets paid by the word. So we have two more of those coming out. One is going to be based on a server platform. One is going to be based on another desktop platform that has more updated drivers. Something you'll see called a DQ77MK. Something the lawyers don't want me to call Maha Bay anymore because we don't use the code words after products have been released. But that is the same kind of model. It's a consumer product, so it's stable hardware. We've put out a special version of the BIOS for it that has debug options, so you can get the debug strings to come out of the serial port. In some cases, you can enable source level debugging for your drivers or UEFI preboot applications. However, it has a limited number of models. The firmware is distributed binary only. We're not, for various legal reasons, giving out the source code for it. It's not a project you can get out of Tiana Core. And the hardware itself isn't an open design. One of the things, if you release source code out into the world for hardware, there's sort of an assumption that you have all of the pieces you need to work on the hardware. Schematics, information on proprietary pieces of firmware, and the hardware in this case from a consumer desktop board isn't the kind of thing that we just go put the schematics out online. So it makes it hard for people to leverage this type of thing. Lower cost. The development kit isn't a really cheap option. I mean, when you look at it, if we sold the previous development kit for $1,000, you went to your boss and said, I have to buy something for $1,000 US. That, in the computer development world, that's actually an inexpensive tool. I personally have an Intel ITP that I carry around in my luggage. It's a little blue box that I can connect to a CPU, and I can use it to debug CPU instructions. That's the most expensive thing in my bag when I travel by a factor of 10. It's way more expensive than my laptop. It's way more expensive than my luggage because I bought my luggage at Costco, so that's not very expensive. But $1,000 for a hobby developer, for a startup, for someone who's doing this in their college dorm room, $1,000 is a lot. So that's maybe not the best place to start. And also, if somebody's doing a small development, say that I decide one day, I get tired of working for a company that actually has a travel budget and marketing, and I want to go and start up my own little company. I want to do more on that board than just play around with the firmware or try the operating system. I may want to add components. I may want to build my own custom hardware and have it interface with the board, which means I need to have the schematics. I need to have a design that's more easy to use. And the third, again, is open source. And Intel and a lot of the UEFI community in general has been very willing to adopt open source development. So tianocore.org, the core for EDK2 is in that area. And it makes it easy for different companies to come along and leverage that into their products. It's done as a BSD license if you're not familiar with it. It's not GPL. So if you make changes, you don't have to necessarily return them, which is good for a lot of the product development we do. And it also still is compatible with people who want to come in and do bug fixes, recommend changes. Now, Secure Boot is a very good example of this. The Secure Boot implementation in tianocore was improved by recommendations from OS vendors. They would look at our implementation and go, that doesn't look very good. And then they would come along and fix it. They would email us and say, this is wrong, this could be exploited. This isn't the best way to do it. What if you put an empty key in? Does something bad happen? And we're able to make those improvements. But if you want to take that out and put it onto real hardware, EDK2 is actually very hard to do that. There's only a few samples of that. Arm was talking about the PandaBoard project. That's one of the few things you can actually take as hardware, take EDK2 and build onto a real piece of hardware. Well, it's good for them, but for a lot of the other developers in the world, that hardware doesn't meet their needs. So the open source developers who want to go out and mess around with options say that they want to test an option that isn't enabled by default on the UEFI development kit, but it also couldn't be enabled on ARM for whatever reason. There's no gap in between. They can't take the project and say, what if this was configured differently? How would my operating system behave? Or could I integrate the operating system more closely with the hardware? So of course, I'm an engineer. I've labeled a number of problems. Obviously, I have a solution. Well, hopefully it's a good one. Where we see the gaps now in our development is not client and server. The adoption rate there is very, very good. It's in, and I hate this word, embedded. Embedded is what marketing people try to do when they cannot describe a market area of computing. They just say, oh, it's embedded. Embedded is every type of special purpose computing. So cell phones used to fall into the embedded development model because they were small proprietary pieces of hardware. That's changed quite a lot. Industrial computing, the kiosk at the airport I'm going to use tomorrow when I fly home. I scan the barcode for my ticket. That's embedded computing. The turnstile at the MRT where you scan the card and it checks to see if you have any money left and lets you take the train. That's embedded computing. And a lot of people who get into what we consider to be hobby computing are really doing embedded type of work. They might only want to make a few hundred boards, but they need something that they can leverage. And they also want something, if you're going to get young people excited about something, it has to be what they call hackable. Meaning if they take it out of the box, it's designed to be changed. It's designed to be messed with. And if it's easy to change and break, then it needs to be cheap because you're going to go through a lot of them making mistakes. And open source. It would be nice if people didn't have to sign NDAs to do things. I know at Intel we love our paperwork, but that's not going to get more people into the industry. Now, if a lot of this sounds familiar, it's because this isn't the first time anybody's had this idea. There's already a good set of developer communities around something called an Arduino, where if you go to the digital market, there was a stall that we saw. I went with some people from Intel and AMI a couple days ago, and there's a stall that sells nothing but Arduino boards. And they have little plastic bags with a circuit board and parts and instructions, unfortunately in Chinese, I can't read it. But it tells you how to make a circuit to attach to the standard board. There's the Beagle board, Panda board, lots of little boards named after animals that are used for ARM development. And those have projects in Tiano Core, but again, as Arm was describing in the previous presentation, a lot of those boards aren't using UEFI as the default method. They haven't converged on it as the standard way to boot. It's a project someone has to take and then get the UEFI firmware, build it, and put it on. So it's multiple steps to get to UEFI out of the box. Now, someone at Intel in our open source community, a project called Yocto, which is one of Intel's many Linux projects, decided they wanted to have a similar type of board available, but they wanted it to be UEFI first, because they saw that as where the industry was converging. And so that group, it's actually a very nice cooperation within Intel. It's a cooperation between multiple departments. It's the Open Source Technology Center, OTC, and my group, STO, are working together to have the firmware and operating system and hardware design jointly developed so that we can take advantage of this Minnow board. And this is a product that Intel is going to be putting out for sale sometime around April or May of this year. It's based on an Intel Atom CPU, which is a smaller, lower power option. It's designed also to be fairly inexpensive and an easy way to start into embedded development. And again, this is built for, in the United States, we refer to this as a maker community. These are the people who would love to have something like the digital market to go to every night and buy parts from and play around. In the US, if you want to buy those kind of parts, you get a catalog and you order them from the mail. There's a chain of stores in the United States called Radio Shack. And when I was in college, which was a larger number of years ago than I wish to admit in public, you could go to a Radio Shack and buy components. They would sell you resistors, they would sell you transistors, they would sell you a 555 timer and a breadboard. Now if you go to Radio Shack, they will sell you a television and a cellular phone, which is a little depressing. So people will go through it, but they'll order parts and they'll try to build these type of things. And they make helicopters and cameras and they make little boards and they put them on balloons and they go into space and take pictures. There's a lot of neat stuff that happened in this community. So we wanted something that was powerful enough or more powerful than the options they currently had from the different small form factor boards. But also, when it came out of the box, it was useful as a full development system for Intel architecture. So not just the open source items for the OS, but also all the way down to the firmware. So a few technical details, and I'm not going to go into this too much because all this information is out on the Minnow board website, and there's also a few wiki pages on eLinux that are dedicated to the expansions for this. But the processor's an Atom E640, which is an embedded style processor. It is 32-bit. So this is actually another interesting thing, is that the firmware will actually allow us to exercise the IA32 processor binding in UEFI, which is something that hasn't been as well exercised as the x64 or the ARM binding so far. So this actually gives a lot of the open source people, when the Linux people tell me, hey, I have this IA32 code, what do I do? And I'm like, I can't test it on this because it's 64-bit firmware. There's 1 gigabyte of DDR2 soldered down to the board. It has a large number of expansion ports. So standard USB, PCI Express, not by 16 because it's a small board. SATA, there's a built-in gigabit Ethernet. There are also a number of industrial-style expansion buses. So you have SPI for the flash. You have your standard GPIOs. There's an I2C bus that's accessible. There's a CAN bus. Anybody in here actually ever worked with a CAN bus? Yeah, that guy. CAN bus is an industrial control bus. If you've done any work with industrial controllers, things that are typically powering factory machinery, they take real-time operating systems, we get report status from this. So it allows you to interface with a large number of small form factor devices. And if you've been paying attention to UEFI development, we're trying to standardize I2C protocols. So this actually gives you an interesting board that has an I2C bus ready to try this out. There's also an expansion board system. Again, since I went to college back when Radio Shack would sell you individual parts, I'm also familiar with an old standard called PC-104. PC-104 was the idea that you would buy module boards, and if I was going to make some kind of crazy computing device, I wouldn't have to build all of the components. I could buy someone's PC-104 computing board, and then I could take my modules and stack them on top. It had a large pin header, and it would pass the bus up, and you could put them, it almost looked like a giant soda can when you finished connecting it. You would stack all these boards on top of each other and stick them in an industrial enclosure, and then plug power into it. We're going to do the same kind of concept with called lures. Now, since they named the board minnow after a fish, things that you attach to fish would be lures. I'm not the guy who came up with the word, but whatever. It's kind of clever. So the lures are going to be based on a open connector. We're going to use a standard connector. We're going to tell everybody what the pinout is. There's no licensing fee, unlike, say, the different standards that are out in the world. PC-104, Q7, these kind of industrial bus interfaces tend to have a licensing fee. This doesn't. And we're also expecting this to be an under $200 item with all the pieces you need with the UEFI firmware already installed. So it is an out-of-the-box usable system. So power supply, general cables are going to be available. From a UEFI standpoint, again, the default firmware is going to come as a binary image. We are going to be implementing a stock firmware, a UEFI 231C with fastboot enabled. So this is going to be as close to a feature image as possible. The unfortunate thing about what we do with the development kit is we spend so much time putting debug features into it, we don't do a lot of product style optimizations like making the boot faster. We are going to be doing that with the default firmware here. Now, this is an open hardware concept, which means the schematics for the board are being published. That makes it easier to debug when you want to change things or figure out maybe we can do something right in the first version of the image, and you want to report a bug into the open tracking database. Now, we're also putting a 4 megabyte SPI flash part down. We're putting a DediProg standard SPI header next to it. It's not going to be socketed because who in here actually likes SPI flash sockets? No one. We know they have short lifespans. We know they break. I've broken far too many of them in my life. So we're just going to put the header down so you can take a standard DediProg, which is not that expensive, and just put it down on the board. Now, 4 megabytes, this is not a system that has Intel active management technology. It has none of the ME code. So all of that 4 megabytes is available as a descriptor for the firmware. And we're not going to use 4 megabytes in the default image. It's probably going to be closer to 1.5 megabytes. So there's a lot of room for people who want to go in and try different things in the flash. There's enough room to embed an operating system in 4 megabytes if you know how to manipulate it. So this gives you a good style development platform if you want to hack around with the hardware and try to make changes. Now, one note that's not on the slide, because I didn't have the information beforehand, the secure boot feature is not going to be present in the initial release of the firmware. However, it is going to be added to one of the official binary releases. So at some point, there will be the option of enabling and testing secure boot with the IA32 product, which again has not been something that's been in the market as of yet. And since it's open source, if people have issues, they decide their product build doesn't need secure boot, they have the option of taking them off the route. So again, with the firmware options here, we have kind of two different audiences for this. One is the audience that just wants the board for testing, or wants the board for hacking. They take the binary image as it is. We have multiple different types of images available. The initial OS target for this is Yocto, which is our open source project. Yocto is more of an embedded mini-style Linux. So we'll have a payload that boots to Yocto, a payload that boots to the shell, and of course we have the opportunity for other open source hardware or open source software vendors to build their own payloads. If you need to make changes to it, it's a shell-based utility. or if things go horribly, terribly wrong, you can use the SBI header to do the reprogramming. Now from the source code side, we are going to put a buildable project into Tiancore. So there is going to be a way to, just like you do with NT32 or OVMF or the various ARM projects, pull the tree down and build a project. There will not be 100% source code for this because some of the items that are provided for the Intel chipset are binary initialization. So there will be a binary like with the video option hop, or with the LAN driver, or with some of the parts of the initialization. But these are things that we don't expect anybody to have to change. So you wouldn't need to change the video option hop, for instance. So that would be distributed as a binary because it's just going to do the basic initialization of the DVI connector. And we are using a standard DVI style connection, so there's no HDCP in the way. So that doesn't interfere with different types of video devices you might want to work with. So again, this is something that Intel will be releasing later on in the year, but the main target for it isn't really UEFI development. The main target is trying to encourage more open source development in the embedded space, but because of the different things that they're doing with this open hardware concept, it's very easy for us to use it to try to also extend UEFI development as well. Now, my team at Intel in SSG is not going to abandon the development kits. The development kits have a different purpose, and there are a lot of things that MenoBoard can't do for adding part vendors testing. It doesn't have a PCI Express by 8 slot on it like our server board does. It doesn't have 64-bit firmware that we need for testing mainstream operating systems. But it is a good embedded platform. It's designed to be lower cost. It does allow x86 developers to get a lot of the advantages that other open hardware products have already had, and especially leveraging UEFI. And again, since we're dealing with open schematics, we're not having to force people into the NDA process and the CRV process like we do with mainstream development. But since it's on the Atom line, it's not in competition with anything that we're doing with our standard development practices. So it's also good for me because when I travel to Plugfest, this is much smaller than my server, so maybe I can go through customs a lot faster. If you need more information, I've included 3 main links in the back of the presentation, and I know that these are going to be made available on the UEFI website. One is the MenoBoard project, which has its own website and has a Twitter account to follow for updates. There are also some people with MenoBoard. If you use Google+, you can find them and take updates there as well. A second is Intel's UEFI Community Resource Center, which is uefidk.com. We're taking a lot of the UEFI information that was spread across the Intel.com website and putting it in this side website. That way it's a lot easier to find, it's more focused. It's also where you can download the firmware updates for the existing development kits or order the new development kits. There will be Minnow information and some kind of UEFI developer support for people working on the Minnow project. And the third, hi, I'm Brian. So this is how you get in touch with me if you need to have any other questions answered. Speaking of which, do we have any questions from people in the room? Yes?
Are you going to provide a standard Yocto payload too?
The question is if we're going to provide a standard Yocto payload, and the answer is yes. There will be a Yocto image that is pre-built for this board. And the open source, I didn't include the website for the Open Source Technology Center. It's 01.org. The number 0, the number 1.org, which 1 is very clever, and 2, I can't believe nobody else had registered that already, because that's a cool website. Anybody else? Maybe Tim has another question here. Okay, well, I appreciate your time for this, and this is officially the last slide of all of our presentations. Yay! So again, thanks for attending. If you need more information, our little cartoon fish here reminds you about MenoBoard.org, and thank you very much.